which is video game hacking, right? All right, so a brief history of video game hacking. Video game hacking, when it first came out, looks very different than it does today. Oh,
Sorry.
okay, we're good. So the original purpose of video game hacking is actually used for testing purposes. Imagine today you're in like a very old console game where you have to progress through all the different stages in order to reach the final goal. They might not necessarily want to play through the early stages, which has already been tested. So developers oftentimes put in specific code that you can type in order to jump to a specific part in the game. And so that's our first cheat code. And then eventually it sort of grew from there. It's like you have cheat code that maybe give you more health, cheat codes that give you infinite bullets or ammo. We also have action replay, which people might be familiar, especially with Pokemon. And then after cheat codes, there is the peek and poke method. The peek and poke method essentially says you want to look at a specific memory address. That's called a peeking. And then modifying that specific memory address is called poking. So for example, if you find the memory address for, let's say, the currency in the game, you can then poke at it. So you change it such that you have a lot more money than you're supposed to have. And then with the emergence of online hacking, with Peter, can you mute yourself, by the way? We can't hear you type. Okay.
Sorry.
It's fine. Sorry. And with online hacking, there comes other methods of cheating, such as creating artificial lag for your opponents, maybe looking ahead or special vision, such that maybe you can see your enemies through a different wall. And then, of course, the infamous aimbot and trigger bot, which we'll talk about in the next slide. Next slide. All right, so what is the aimbot? Well, an aimbot is essentially a program that helps you immerse the cursors to a specific part on the enemy entity. And it's mostly in first-person shooter, and it basically like snaps onto the head of the target. And with addition, if you add on like a trigger bot to it, you will be able to instantly fire. We have a short clip that we wanted to show you. Ted, can you play it? Yeah, so essentially, as you can see, especially in the final clip, that his movement is extremely jerky. He doesn't seem to be actually doing the aiming himself. And then he can also shoot through walls, which is something that you normally wouldn't be able to do. And next slide, please. We can stop playing the video. ESP, or in this case, the looking ahead, or the what we call the extrasensory perception, basically highlights the enemy and maybe something that is out of your covered by a specific target or an obstacle. You'll be able to see them, as seen in this picture here. They'll be outlined in a green box. And a trigger bot simply means that as soon as a target moves into your specific line of sight, you immediately fire. It's like near instant reflex. Let's talk about internal hackers. Internal hack essentially injects DLL into the game process. It gives you access to the game's functions, also the game's memory. They're harder to detect because they're considered part of the game, and they also have better performances because they don't need system calls. On the other hand, we have external hack, which is a separate process from the game process. Oftentimes, you need the pipeline to in order to access the game's memory and also to modify it. And most of the time you use methods such as read memory and write memory. But The downside is they're easier to detect since they don't use a gain function. They're hard to execute and they have a lower performance due to the overhead from using system calls. Yeah. Next slide. And here's the demo.
Okay, so this is where we were going to show a CSGO demo, except CSGO just updated like right when we started the workshop. So I'm not sure if our hack will work because the offsets for some values that we need in the hack might have been changed by the update. As you can see from this note here that offsets may change. Haze Dumper is, they provide the offsets for free. They usually go look for it every update, but since the update just came out, yeah, it might not work, but I will try it anyways. So I'm going to, yeah, and I'm not going to go over like how we made the hack and how it's injected just yet. We will get to that, but I'm going to share my CSGO and see if this actually works. Yeah, really unfortunate. We might be able to fix it after this, but yeah, let me try. So so yeah, I've launched the game in insecure mode so that VAC is not activated and I don't get banned. Yeah, here, let me show my whole screen. So this is our CSGO aimbot. So I'm going to open it up and I'm also going to open up the injector that I made, which I will go over in a bit, but yeah. So for now, I'm just going to, yeah, I don't think this is going to work, but I'm going to go into a bot aim and see if this works. So I'm going to build actually, I don't need to build it. I'm going to inject. We will be going over all this later. Just bear with me here. All right, what's going on in the chat? Yeah, simulate the aim. All right. Maybe I shouldn't have injected while I was loading. I went on Steam to launch CSGO. It just got the update right when we started. Okay, it crashed. Yeah, I don't think it crashed because of the update, but let's just okay. So multi-level pointers explained. So I'm going to go over a little bit of prereq information that you will need to understand the rest of our presentation. So yeah, so here's like a quick review on multi-level pointers. So they're just pointers that, point to other pointers. So they're often used in games. For example, we have this, this player actor on the right of our screen. Here's some sample code. So we have a pointer, a local player actor pointer, and in that actor struct, we have a player pointer. And in the player struct, we have the inventory pointer, and in the inventory struct, we have the ammo pointer, and you get the idea. So one example that we will be using in this presentation is the bone matrix, which Peter will be explaining, and that it does consist of multi-level pointers. So wait, hold on. Okay, so sorry, what is a handle? So in Windows 32 programming, a handle represents the a resource managed by Windows. So you can think of it kind of like a pointer. It is distinct from a pointer in various ways, such as not being able to dereference it and um, and some other distinctions that you can look into on your own. However, what you need to know is that we will be using some handles since we're using the Windows API. And it's just a way to work with a resource without working with the resource directly. So like a pointer. Um, and yeah, so finally, what is a DLL? Well, a DLL is a dynamic link library, and it allows code to be, it can use code in multiple programs using the same DLL. So one copy of the DLL for multiple programs. It's also useful for games. It allows us to save memory space because we only have one copy. And it also is allowed to be loaded in and unloaded during runtime. And this is an important property because we can use this property to do things like DLL injection, which is how we would inject a hack into a game while it's running. So it's much harder to detect that way. And it would inject it directly into the memory space of the game. So, so let's go into more detail. What is DLL injection? So it's not what this picture is showing. It is actually just forcing a process to load a DLL. So it basically allows us to load this DLL into the address space of a process and run our code. Usually this code will be like something non-malicious, like something that helps the program run, or has some nice functions for the program to use. But in our case, we're going to be injecting our cheats. So there's multiple methods in Windows. I kind of outlined a couple here, like putting a DLL in a specific registry key, which is loaded into many programs, or this registry entry. However, the method we will be using is to actually utilize the Windows API and call the Windows API functions to kind of, in a legitimate way, do something illegitimate. So all we're doing is using Windows API function calls to do this. So before I go over some code, I'm going to kind of outline the process here. So step one, so all these steps will be taking place in a separate injector process, which is separate from the host process. So the host process is here. So in step one, we just have the regular host process and we attach the injector using open process. Step two, we have the host process here, and we call this function called virtual alloc-x, which is basically virtually allocating memory in an external program. So this gray box here represents the memory that we've allocated in the host process. In step three, we write to that memory, so write process memory. So that would take in the address of the memory and then what we want to write. And so in this case, we want to write the DLL or the DLL path. Those are both legitimate ways to do it. In our case, we're going to be writing in the path to the DLL. And then this create remote thread function will execute that DLL and within the address space, the memory of the host process. So then at that point, the DLL will be injected. So it'll be running in the host process. So now I'm going to show you what that looks like in code. Oops. All right. So here we have a sample injector. I think you can see this, right? Yeah. All right. So overall, this function or this program is just two functions. So we have this get proc ID and the main function. So first I'll go over what the get proc ID does. So essentially what it does is you give it the name of the process and it gives you the ID of the process. So how do we do that? Well, first we use this Windows API function, which is imported from this Windows.h header include has a bunch of different Windows API functions that we can use. So we can use this snapshot, create snapshot, which basically grabs a list essentially of the processes on the machine. And hsnap is the handle that we declare. So remember when I talked about handles, it's basically just a way that we can work with this snapshot resource using specific functions to do so. So we're not working with the snapshot directly, but we're going to call some functions on it that work with this handle. So now we move on to creating this proc entry struct, which basically will store each process entry from the snapshot. So here we call this process 32 first, and it basically loads in the first process from the snapshot into this proc entry. And then we do a simple string compare. We see, okay, is the file, the name, does it match with the name in the process list? So if it does, then we grab the process ID by grabbing this process ID from the proc entry, and we break if we found it. If not, then we just go to the next process, load it in, and do the same string compare. So we do that until we find the ID. So now get to the good part. So we just, we have a basically string here with the file path of the DLL, and then we have the process name. So for example, for the CSGO cheat, it would be wherever I have the CSGO aimbot DLL, and then the name would be csgo.exe. So this is grabbing the process ID given the name of csgo.exe. And then so this is the step one in that diagram I showed. So open process, we attach to the process specified by this ID that we got from our function. And then we use the step two, virtual alloc x. So these are just like, these if conditions are just error checking. But so yeah, step two, we virtual alloc x. So we have all these flags here that we're passing in. Yeah, it's just some things that you can read on the documentation what they are, but the essential parts are to get the process. So specifies what process and giving us read-write permissions to that. And then it'll allocate the memory and return the location. So now we store the location here. Then we do step three, which is write process memory. So yeah, we're writing the DLL path into the process. So we specify so I wrote down a little template here. So write process memory, the handle to the game. So this process that we got from here, the location that we want to write to, which we got here, the variable containing the value to write, which is the path, this path. The size of it, so we just take the string length, and then we don't need to worry about this last flag for our purposes. And then finally we execute it. So we use create remote thread, we specify the process, blah blah blah, and then we call this load library A, which will load whatever is in this memory location here. And in that memory location is the the file path. So it's going to load this DLL, and then we will have a thread in the host process, which is the game running the DLL. So then we just close the thread, close the process handle, and we're done. So yeah, so that was a bit lengthy there, but just to go into detail for that. And now that we know injection, then we're going to actually go over how do we create the hack that we're going to inject. So Peter will be over here. Yeah.
Unmuted. Okay, so now we know how the injection works. We're going to talk about one method of hack, specifically how to create a internal aimbot. So before we get started, a little overview of what we want to do. So first, well, in order to create an aimbot, we need to find the closest enemy to the player. Once we find the position of the closest enemy, we want to calculate a vector from the player's view angle, which I'll explain later, to the enemy's head. And then we want to rotate the player's view angle to that particular vector so that the player is always aiming towards the closest enemy's head. Next slide. Okay, so the entity list. So in order to get the closest enemy, we need to be able to get players' addresses, right? So this is a simplification of how CSGO represents entities or specific players in the game space. We'll also skip over how to find the base address of the entity list. That can be done through like reverse engineering. But essentially, think of the entity list as an array of entity pointers. And each of these pointers points to a specific player entity. In that player entity is information such as like their health, their position, how much ammo they have, their view angles, and so we'll need that in order to access, for example, the position. The little code snippet here, what I'm doing is I'm grabbing a handle to the client.dll, which will contain the module base address, so that we can offset to this particular entity list, which I added here. And then what do I return? I return the entity list given a specific index, and I multiply that by 10 bytes because there is a offset between each entity pointer of 16 bytes. And then I cast it as a player pointer because I'll be working with a player struct. Right, so next slide. So now finding the closest enemy. So now I'm able to get any particular player in the entity list. What do I do now? So first step, just loop through all players in the entity list. As you see here, I am calling a function, a getMaxPlayer, which specifies how many players exist in the game currently. And I'll just get the player at a specific index in the entity list, store that as a pointer to the current player. And now with that, I can also get the position of the player using the function getOrigin. And there's this little thing here, right? What is this? uint pointer t pointer dereference it this plus vec origin. Like, what does that mean? So specifically the uint pointer t pointer dereference is something that's called type punting. Uint pointer t is essentially an unsigned data type that can store a pointer of 32 bits. So just think of it as like a generic pointer, right? And so when I dereference it, I get the address of the actual pointer. Why do I specify it as a uint pointer? It's because I want to be able to do like pointer arithmetic with it. And so I guess what's the point of doing that? Like, why not just cast it as a uint pointer t? The reason is because if you just do that, then your compiler will complain. So type punting is a way to sort of evade the compiler warnings and complaints when you cast a particular type to another. So it's just a C++ thing. And essentially what I'm doing is I am adding some offset, which would be the vector origin or the position of the player. And then that's going to return a vector 3 pointer, which essentially contains the x, y, z coordinates of the player within a vector. And then with the third function, I will need, let's see, the Pythagorean theorem, right, to get the distance between the player and the closest enemy. And so what I do here is basically I take a vector 3 to some other entity's position. I get the origin of my own player's position, and then just do Pythagorean theorem in order to get the distance between some other player and my location. So another concept we need to understand are view angles. So in the diagram to the right, just imagine if I look straight ahead, there's a coordinate plane. So in that case, right, this XZ plane, my view angles are 0. If I start looking up, right, if I start tilting upwards, we call that pitch, right, because I'm rotating about the horizontal or x-axis. And typically in games, that is capped between -90 degrees and 90 degrees, because we assume that the player can't just like bend backwards and see like what's behind them, like, you know, Neo in the Matrix. And then yaw is looking horizontally. So if I turn left and right, I can look behind me, and that's the range between that is -180 degrees and 180 degrees. Something interesting is that the coordinate plane for CSGO, which uses a modified version of Source Engine, has the up direction as the Z direction. If you worked with Unity, for example, and a lot of other graphical, I guess, engines or video game engines, typically it's like Y up. So that's one thing to note. So all the calculations from here on forth will be assuming that the Z coordinate, Z axis is up. And so how can we calculate pitch, right? How can we calculate how far I need to move tilt up essentially in order to aim at the closest enemy? So we can do some trig here. I'll draw an angle from the player from point A, right, to point B. But in order to do that, right, I need to make sure the vector starts at the player's head, at my head. And so in order to do that, we have to add the view offset, which will be some sort of value. And then I can just draw the vector from A to B. And then I can do a little math here, right, to find alpha, which is the angle I want to find that defines the pitch. So something interesting also with CSGO is that pitch is negative as you move upwards, which is a little bit counterintuitive. Don't ask me why, I'm not sure. But yeah, we can use just simple trigonometry to find this angle, right? Arc sine of Z over hypotenuse, which is right opposite over hypotenuse. And that'll give us the pitch angle in alpha. And then similarly, right, if the player is like, or the enemy is like to the left or right of us, we need to move horizontally to determine what the yaw angles are. And so we'll use just arctan of y over x, and don't forget to add the view offset. And so now we have the view angles, but how do we actually know where the position of the enemy's head actually is? So one concept we need to understand as well is the bone matrix. And so what is the bone matrix? Well, the bone matrix is an array of bone objects. What is a bone? A bone, essentially, you can think of as a point containing, right, x, y, z coordinates, and it represents a particular position on the skeleton, right? And the bone matrix will essentially contain a list of these points or bones, that specify a particular bone. And so to the image of the right, we can see that, these are the bones are numbered, right? One thing to note though is that depending on which model you're working with, the bone IDs will be different, right? So for example, the arm of one model that bone ID might be different from the arm of another model. But luckily for us, all models in CSGO, the bone ID of their head is 8. And so this is pretty important, and we'll leverage that. And so, here's just the code defining how we get the actual positions of the enemy head, right, or a particular entity's head. So the first thing we need to know, right, is the entity list. What is a D word? A D word is a Windows thing. It just means, it's short for a double word. it's a double unsigned integer, right? And so if you remember, unsigned integers are 32 bits. So coincidentally, right, 32 bits, what is 32 bits? Our memory address. So what we're doing here is we're essentially reinterpreting this as the like raw memory address, and we're just doing additions, right? Because this code is going to be running within the memory space of CSGO, right? And so we can directly work with the memory address and these offsets to get what we want. That's why we're doing this dword pointer dereference type punning type stuff. And then, so let's say we know the offset of the bone matrix. Then we add 48 bytes, which is the size of the bone matrix, multiplied by 8, which is our bone ID. And then we add 12 bytes. Why are we adding 12 bytes? Well, a 3x4 matrix, let's see, is 48 bytes containing 12 floats. We can think of this as containing 4 vectors of x, y, and z. We can also, if you remember, if any of you guys have taken CS33, there's something called alignment with objects, and basically a certain amount of data needs to be padded, or they have to be divisible and by the same number, such that the compiler as well as whatever is, I guess, accessing the memory can do so in an efficient way. So it's a very much an optimization method, and using reverse engineering, we can find that the x, y, z positions are at the offset of 12. And so, yeah, once we get the x, y, z coordinates, we can summarize our total hack. Next slide. We can summarize like what we've accomplished. So in this internal hack, we scanned the game in order to find the closest enemy to the player. Then we calculated the pitch and yaw, right, from the player head to the enemy head. And then we overwrote those view angles that we calculated to the actual view angles of the player. And so one more step I'd like to go over is just the main method in the DLL. So if you can click that link. And zoom in a little bit. Yeah, so we have 2 functions, right, on DLL attach. Essentially, that's going to be on our process. It's going to, once the DLL has been successfully attached to the process, we want to spawn a console. And
you want to share this?
I can share that.
Yeah, so you can like select and stuff.
Okay. All right. So yeah, basically what we're going to do is that once our hack has successfully attached to the process, we'll spawn a console and just let us know that, you know, we've successfully attached to the particular process. Since this is going to be running on a thread, right? The injector spawned a thread and is going to be executing our code. We can say that, you know, if delete key is not called, if we're not pressing the delete key, we'll just call this run function. And what is that? The run function essentially will contain our hack, and it'll be running in memory. Some other things we need to note: this DLL main function. Yeah, this basically is like a main function that will be triggered when we attach to the process. We do some optimizations here to prevent this from being triggered when a particular like library thread is executed or a specific library call is made. And then yeah, we just create the thread here on this particular event to execute within the virtual address space of the process, which is CSGO. So hopefully that was a good explanation of the internal hack, and then Henry will be explaining the difference with the external hack.
Yeah, Ted, do you want to keep sharing, or do you want me to share?
Okay, wait, actually, the CSGO hack still works. Should I show that?
Let's
really quick?
finish the
Okay,
external
yeah.
hack first. Why don't
You want to share it?
yeah, you keep sharing.
Well, okay.
Okay. So, yeah, here. Yeah, this is fine. So basically, I should go back. Is this the one? I thought there was one before this. Yeah, this one. You skipped it. Okay, you know what? It's fine. It's fine. Don't worry about it.
Ew.
So there was one with an overview. Yeah, this one. Yeah. Okay, so basically, I'm going to be covering how to create the external hack. Like I introduced previously, for external hack, you're going to need the read and write in order to access the game's memory externally. There are some more different steps that we need to take in addition to the ones that we took for the internal to make the external hack work. So the first thing that we had to do for external is we had to attach the hack to the process. This is done by setting a pipeline between the hack and the game itself. And then for step 2, these 2 to 3, these will be similar to what Peter just covered. We'll go through the entity list, and then we'll find its position, get the coordinate, and then we'll calculate the specific offset to find the head bone of that specific character. But then before we actually adjust our angle, we also had to take into account, we need to convert the world position to the screen position. And the main reason being that when we use internal hack, the position of it on the screen is made available to us as well. But when we use external, we need to convert the object in the 3D plane into something that we can see in 2D, and then we can calculate the view angle to shoot. Next slide.
You want this slide or this slide?
The one after this one. So establishing connection. So essentially, for our purposes, I used the null terminator, and essentially you just get the module and you set the base address of it into you put the specific game process that is running. It's not called client paranova anymore, it's called client.dll. And sometimes you might have to export the process name, since they use they export it when they inside the actual memory. So you have to do that in order for it to match up, so you can get connect the process together. Next slide. Okay, so similar to internal hack, once we have the base memory of all the players, all we do is we simply loop through, and then we find the bone ID for that specific. And then after that, all we had to do is calculate the world position, and then we had to calculate the view angle. So on the right hand side, you see we have a for loop. We just simply go through every single one of the players. And next slide. All right. So I think the most complicated part about external hack, especially for a first-person shooter, is actually the world to screen. So what exactly is world to screen? Basically, imagine today that on the other side of your computer screen, there's a 3D world. But how do someone who's actually looking at the screen know, or how do we convert the data, such as the X, Y, and Z coordinate of these specific objects, onto the screen, so whoever's looking at the screen knows that, oh, this object is in this position. So to do that, there is two things we need to know. One is the view angle, or sorry, not the view angle, the current set of line, and FOV. So in this diagram here, you can see the blue dot is where you'll be, and then we have a FOV, which is the green line, and then we have the screen plane, which is kind of the 2D plane you're looking at, and then we have our enemy. And the goal is to adjust the current set of line to the aim angle, so we can shoot the enemy. Yeah, next slide. And on the right-hand side, you can see a better picture of the 3D plane to 2D. Yeah, and there's another picture. So line of sight normally points normal to the screen. It points into the screen essentially. And like what Peter talked about, there is a specific yaw and pitch that we have to adjust in order for it to point specifically at the enemy. Next slide. So how exactly do we obtain this specific angle? Well, this is done first by subtracting the camera to the local object to the camera to local to the camera to the object. So the camera is basically the set of line, and then the camera, there's also a specific angle from the camera to the specific enemy object. And we use that to calculate the relative yaw. And this is done by taking the yaw, like the angle, this offset from the camera to the x-axis, and then we take the offset from the camera to the object according to the x-axis, and we subtract it to get a relative angle. Next slide. And then for the yaw, so like Peter said, we're going to have to adjust it accordingly, because this can go from, you can go in multiple degrees, so you can go like -260. However, we're going to do some trigonometry to limit it to -pi to pi. However, after we do that, we also want to further do some manipulation of these specific points such that we can adjust it to the specific screen resolution of the viewer. So what we do is we simply divide by half of the x field of view, and doing so will give us, instead of -pi to pi, we'll get a value that is -1 to 1. And then by adding 1 and dividing by 2, we can get a value that is 0 to 1. And similarly, we can do something similar to the y-axis. And this allows us to convert it to give us a y position from 0 to 1 on the screen. But what do we do with this y position? Well, all we have to do from this point on is we simply multiply it by the screen resolution. And if we take the bottom left corner as 0, 0, then we can easily determine where this object is going to be after we do this calculation for both the x and y coordinate. And if you want to read more about the world to screen, there's the source you can read, and there's a UCLA course that dedicates itself to like computer graphics, and they cover world to screen in a matter of like 2 to 3 weeks, I believe. Yeah. But this is like a really short crash course of world to screen. Next slide.
Cool. I think we can do the CSGO demo before I get into this, if you would like.
Okay.
All right. Yeah, I was just gonna show quickly destroying bots in CSGO with the hack. So yeah, so we're gonna be using the hack. Peter kind of showed bits and pieces of it in his slides. And then I showed the injector that I'm gonna use. So we're going to inject, so Peter's hack, we build it and create that DLL, and then with that DLL, we inject it to the game. So I'm going to go ahead and inject it right now. So now my aim is locked onto the nearest enemy's head. So as you can see, I'm moving, I'm not touching my mouse, and it's just locked in his head. So then I can just tap away, and headshots ensue. And right when I kill one enemy, it instantly snaps to the next one. So yeah, that's just a quick demo. And then, so we'll be talking about a game that Studio made and how we can create this hack, how you guys can create this kind of hack on that game. But yeah, that was just a quick little demo. And then now I'll pass it off to Mark to talk about how we can prevent hacks in your own games.
Cool. Yeah. So yeah, we've gone over how relatively easy it is to actually inject and make a hack like this. So if you're coming from a game designer's perspective and you don't want to have your multiplayer game just rampant with hackers, what can you actually do? So mainly these techniques apply to games that are multiplayer, happen in real time, and generally have a lot of players playing it at the same time, because if you're playing a single player game, generally you don't care as much if your players are hacking it. So the techniques typically apply to, or if you're playing, for example, a turn-based game, say like Hearthstone or something like that, where every move is pretty deterministic and there's not much interaction, you don't really need to care about players trying to inject different inputs and stuff like that, because there's not really that trade-off between a need to have low latency and a need to make sure that your players are doing the right thing. So how this is actually done is typically servers are set up in a way where they don't ever really trust clients' input. So what that means is, say I'm playing CSGO or something like that, and I want to move my character forward. Instead of sending the server my player's position information, say I move from like 1 to 2 in the x-axis or something like that, I will instead send that I have pressed W for half a second or something like that. So it's on the server to validate what input is coming into it and tell the clients then where players should be in the scene. So that means that all of the logic of the game is set up on the server to prevent players from being able to do things like teleport around the map and do random things like this. Obviously, that does not prevent a player from accessing information like the enemy's positions and just using it to headshot them, but it does prevent players from being able to do things that are outside the realm of what are the defined rules of the game. Other things that can be done to at least detect cheaters, stuff like line of sight. So as you can see with Ted's demonstration, like he's constantly tracking, even though he cannot see where the enemies actually are. Something like that is really obvious if you have some sort of system that is detecting that is happening, because like you're looking at a screen, you can't see any of the enemies, but clearly he's able to see them somehow. If you're tracking something like that and a system's able to detect that, you can get flagged and you can get kicked from the game or whatever punishment you want to ensue from there. Similarly, you should do things to limit information to the client. A lot of concepts that apply to other fields in hacking apply here as well. So you don't want to give them any information that isn't necessary. So an example of that would be like fog of war in a game like League of Legends or Dota 2. If an enemy is in a region of the map that your player cannot see, your client doesn't even receive information about where they are. You'll have information about where you most recently saw them, but you will not have current information on where they are. That prevents you from being able to directly know exactly where their positions are and do things that, such as like an aimbot that would allow you to like figure out where they are and shoot them from a distance. Next slide. There's also other methods that you can do. So asset validation is one of them. So making sure that all of the code that is running in the game is exactly what you want it to be. That can detect stuff like DLL injection to a certain extent. Or you can have more aggressive methods, such as Valorant got some flack for this, for doing things with their Vanguard system, where it actually does kernel level monitoring to see if you're running any external code that could be influencing Valorant as it's running in a match. There's some kind of controversy over that, whether that's like too aggressive for a game, but that's kind of beside the point here. It's just another method that they've used to detect these things. Other games also have human replay reviews. So CSGO has a system called Overwatch, not to be confused with the game Overwatch, that allows players to actually voluntarily watch replays of games to see if players have been flagged for hacking or aimbotting or whatever, and they can actually review the case and determine if they think it's hacking or they're just a good player. And generally, people are pretty good at determining if someone is hacking or if they're a good player. And actually, that data can then be applied to things like machine learning, which then uses all the collected data of players validating and invalidating players' inputs and determining who's hacking and who's not, to then automate the system even further so that you have less reliance on human input. And there's a million other ways that cheating is prevented, but these are just kind of like a good high-level overview of how these sort of techniques are applied to a game. Cool. So that should at least give you an idea of how that's done. Now we're going to show you a game that we have made and thrown together at Studio for you guys to actually hack and make an aimbot for. So I'll go ahead and share my screen really quick. I need to be made co-host, I think, for that.
Yeah, 1 second. Sorry, that was my bad.
All good.
Can I just click on the name?
I think so, yeah.
Okay.
Cool. Yeah, I'm good now. Cool. Awesome. Okay. Wait, let me make sure that it is optimized first. 1 second. Where did it go? Oh my god. I'm gonna close out of this really quick. Sorry. Cool. Let me share. Okay, cool. You guys see it?
Yeah, we can see it.
Awesome. Okay, so we've thrown together this little game. Basically, you just have an FPS controller. You can aim down sights, you can shoot, you can reload, all the normal stuff. And the point of the game is you can press M, and you'll see that little targets will spawn around the map. And as you hit them, every time you hit one, a new one will spawn somewhere else on the map. So the goal is to hit as many as possible in, I believe, 30 seconds. And to encourage you to actually make an aimbot for this, the flag is hidden behind hitting, I believe, like 30 of these in 30 seconds, which I'm sure there's some like CSGO pro out there who's able to do that, but I am by no means a CSGO pro. So your best approach here is to actually make an aimbot that can hit all these targets in a certain amount of time. So it's a pretty simple game, but it gives you something to practice on with an aimbot. So this is built in Unity, and I believe Peter will kind of talk about some techniques that can be done to actually make an aimbot for Unity.
Yep. So I'm gonna share my screen here. All right. Yeah. So some tips about hacking Unity games. We're going to apply the same concepts, right, with CSGO, although there are going to be some differences. For example, Unity uses C#, so the aimbot you're going to be developing will be in C#. There are a couple of steps that you'll need to take in order for you to get started. One is installing Visual Studio. Sorry, Mac users. Although actually, yeah, because actually you might be able to. I'm not exactly sure, but we're using Injection. But yeah, so Visual Studio installer, I installed 2019. One thing is, if you don't have this installed, you'll need to install this .NET development. This is because you'll be developing in C#, and this will give you the .NET framework and .NET Core, which you'll need. So once you have that installed, what you want to do is you want to open Visual Studio, create a new project, taking a little bit, I don't know why. Okay, yes, and then class library. You want to select class library or .NET framework as your template. And then when you create your project, you want to make sure that your framework is .NET Framework 4, because there are certain things that you need to do with that. I don't care about the name right now. Just create. Okay, and now here you'll have like your class files, and then your references. So I've provided some starter code, some boilerplate code for you to get started. It's commented and has explanations of what's happening. I'll review that later. But one thing that you'll need to do is right here under references, you need to click add reference. And because you'll be using like Unity scripts or Unity functions that are included in the like scripting library, you'll need to select the appropriate DLLs that belong to Unity Engine. And to access that, once you download the game, you want to go under Data, Managed, and then some things that you'll need, for example, are like the Unity Engine core module. Otherwise, you won't be able to build the solution. I think another thing you'll also need is the Unity Engine input legacy module to be able to like detect player input, like input.getKey, some functions like that, which might be helpful. So once you've added the appropriate references, in order to build your solution, just right-click, build. That will appear in your folder. So I actually have, for example, this is the actual aimbot, solution aimbot in the project. It'll appear under bin, debug, and then your DLL, whatever its name, will be included here, as well as some debug symbols if you want to help debugging your code. And so, let's see. Another thing you'll need that might be really helpful is this tool called dnspy. dnspy is a decompiler. So if you went to our workshop last week, decompiler basically takes the binaries and tries to reverse engineer the source code. So once you download dnspy, you want to go into File, Open. Again, go to the Manage directory of the game, and we want to look at this assembly-c#.dll, and we want to expand this, and then expand this blank namespace. And something that we realize here is that, wait, these are all the scripts that are attached to Unity components. And so we can actually look at these scripts and easily interpret. We don't have to actually use cheat engine or any complicated reverse engineering techniques to actually figure out what the functions are doing. And so as part of creating the hack of the game, it would be really helpful to try to understand how the game works. Like what are the players' view angles? Like how is movement? How is pitch and yaw being determined? How are the targets spawning? And so this is actually really cool because if you wanted to, you could just edit the class directly and just like delete things or change certain values and then recompile the DLL. That will be, so the changes that you make to any functions will actually be present in the game. And so there actually is a really arbitrary way trivial way to solve the flag for the first challenge that we have up. But that's not worth too many points. And we'll just say that the main goal of the game or the challenge is to try to develop an aimbot that'll be worth significantly more points. What we'll want you to do is once you create an aimbot, perhaps record a little video, share some of the source code with one of the officers, and we'll award you quite a bit of points. But yeah, just note that there is quite a trivial way to find the flag without actually completing the objective. But hopefully while you're doing so and looking around dnspy, you get a better understanding of how the game works. And so I am going to show you how the aimbot could work or how it could look like. I'm going to open the mono injector. This is what you're going to use to actually inject your hack into the game. Or launch the game. So go here. Want to refresh, look for the appropriate process. I found it. I'm going to put Unity aimbot.dll. The class name I specified in this was loader, and the method name I had was load. And so now I just need to scope in. And as you see, I instantly rotate if I scope in to the appropriate target. And so basically you want to use the techniques that we've taught you and apply this to Unity to create an aimbot to complete the objective.